Hello, and welcome to my YouTube channel, Space and Nature. Today, we're setting our sights on the universe's most electrifying mystery. Imagine an explosion that releases more energy in 10 seconds than our sun will in its entire lifetime. These aren't science fiction. They are gamma-ray bursts, fleeting, intense, and the single most powerful phenomena we know. Stick around to uncover the secret of these cosmic giants. So, how could something this incredibly powerful, this utterly spectacular, remain hidden from us for so long? Well, partly because they erupt in gamma rays, a form of light far more energetic than what our eyes can see, or even what standard telescopes detect. Gamma rays are the universe's highest energy photons, born from the most extreme processes imaginable. And these bursts of them, they're not subtle. Picture a flash so brilliant, so packed with energy, that if one happened in our own Milky Way galaxy, even hundreds or thousands of light years away, it could potentially impact life on Earth. Thankfully, the ones we detect are typically billions of light years distant. Now, the story of their discovery is ripped straight from a spy thriller. It was the 1960s, a time of intense global tension. The United States, deeply involved in the Cold War, was anxious to verify that no country was secretly testing nuclear weapons, which would release telltale gamma radiation. So, they launched a top-secret constellation of satellites, the Vela program, specifically designed to detect these gamma-ray signatures. These satellites were scanning for flashes coming from Earth. But month after month, year after year, the Vela detectors registered powerful gamma-ray bursts, not from any point on our planet, but arriving from random directions out in deep space. Imagine the confusion. Was someone testing superweapons out past the moon? The data was classified, a puzzle confined to a small group of scientists and government officials. These bursts were fleeting, sometimes lasting mere milliseconds, other times up to a couple of minutes. But the energy spike was undeniable, unlike anything they expected. It took years and eventually declassifying the data for the wider scientific community to finally understand. These signals weren't from terrestrial tests. They were from the cosmos itself. We had accidentally opened a window to the most energetic phenomena in the universe. These bursts, these gamma-ray bursts, were revealing a level of cosmic power that simply beggars belief. A single, brief flash containing more energy than our entire sun will produce across its entire 10 billion year lifespan. It was a discovery that fundamentally changed our understanding of the universe's most violent capabilities. But the biggest question remained, what monstrous cosmic engine could possibly ignite such an explosion? As scientists studied these enigmatic flashes, they noticed a pattern. Gamma-ray bursts fall into two main categories based on how long they last. We have short GRBs, which typically clock in at under 2 seconds, often just milliseconds. And then there are long GRBs, which can last anywhere from a few seconds up to several minutes. This simple difference in duration turns out to be a critical clue to their incredibly different and equally dramatic origins. So what cosmic cataclysms are responsible for these bursts of ultimate power? The two types of GRBs are born from two distinct, yet equally extreme, events. For the short, sharp bursts, the evidence points towards the most violent mergers in the universe. The collision of two neutron stars, or perhaps a neutron star and a black hole. Neutron stars are the super-dense remnants of collapsed, massive stars. Imagine squeezing the mass of our sun into a ball just the size of a city. When two of these incredibly dense objects spiral towards each other, they collide in a spectacular gravitational death spiral, releasing a massive burst of energy, including gamma rays, and potentially even creating a new black hole. This is also a leading candidate for how many of the universe's heavy elements, like gold and platinum, are forged. Now, the long, drawn-out bursts are thought to be the cosmic death cries of a very specific type of massive star, a star significantly larger than our sun, that's collapsed in on itself to form a black hole. But not just any collapse. We're talking about a rapidly spinning star, often called a collapsar, where the core collapses, forms a black hole, and powerful jets of material are launched outward from the star's poles at nearly the speed of light. If one of these jets is pointed roughly in our direction, we see it as a long gamma-ray burst. This extreme stellar death is also sometimes accompanied by a specific type of supernova explosion known as a hypernova, far more energetic than a standard supernova. Catching these fleeting cosmic events is a major challenge. Since gamma rays are blocked by Earth's atmosphere, we need space-based observatories like NASA's SWIFT satellite and the Fermi Gamma Ray Space Telescope to detect them. When a satellite spots a burst, it quickly relays the coordinates to ground-based telescopes around the world, which then rapidly swing into action to observe the fading afterglow of the burst in visible light, X-rays, and radio waves. This afterglow contains vital clues about the burst's distance and environment. And excitingly, with the advent of gravitational wave detectors like LIGO and Virgo, we've even been able to link gravitational waves from merging neutron stars directly to short gamma-ray bursts, opening a new window into studying these incredible events. So, why do scientists dedicate so much effort to studying these brief, distant explosions? Because gamma-ray bursts are cosmic gold mines of information. Their immense power means they can be detected from billions of light years away, acting as beacons that allow us to probe the conditions of the early universe, when stars and galaxies were just beginning to form. They're also crucial in understanding the extreme physics of black holes and neutron stars, pushing the boundaries of our physical laws. As we mentioned, the mergers that cause short GRBs are prime candidates for the cosmic factories that produce heavy elements essential for planets and life as we know it. Studying GRBs helps us piece together the violent history and ongoing evolution of the cosmos. From an accidental discovery by spy satellites, gamma-ray bursts have revealed a hidden layer of extreme power and violence in the universe. We've learned that these brief, blinding flashes are the death throes of massive stars or the cataclysmic mergers of ultra-dense cosmic remnants. They are not just spectacles. They are cosmic messengers, carrying information from the distant past and teaching us about the most fundamental forces and elements in the universe. They remind us that even in the seemingly tranquil vastness above, incredible, powerful events are constantly unfolding, shaping the cosmos in ways we're only just beginning to understand. Thank you for joining me on this journey to explore the magnificent and sometimes terrifying wonder of gamma-ray bursts. If you enjoyed this deep dive into cosmic power, please hit that like button, subscribe to Space and Nature for more journeys through the universe, and let me know in the comments what space wonder you'd like to explore next. See you in the next video.